This is coding projects at 2.4 for CPSC2100. And in this project, this problem set, we're supposed to basically do the same thing that we did on the third part of our last problem set. And that is to figure out the lowest monthly payment it would take to pay off a balance of $5,000 in a year at 18% annual interest rate. And this is supposed to show you a different method to do a bisection search. And also, it seems to improve utility for the code that you're creating, because you can use it in other places as well, which is really cool. That's a really handy thing to know how to do, because I imagine it will save you a lot of time in the future. So we're going to go ahead and get started. And I've got the problem, the third problem from set 2, over here, just to show kind of the differences as we go. But I'm going to go ahead and start here. And as you can see in the first one, in problem 3 set 2, you start off with your variables, then you go into a while loop. Whereas in this one, in this method, you're going to create your function first. So we're going to go ahead and create our function. We're going to find payment, and these are the variables that it's going to be able to take in, or the arguments it's going to be able to take in. Balance, annual rate, low, and high. And so now we're going to set some variables that are kind of played with inside of the function, which are payment, and that is the lower payment plus the higher payment divided by 2. So you're going to get an average of the two, the low and the high. And then you're going to set your new balance. It's going to be equal to balance. Okay. And then we're going to get into our for loop. So for each month in the range of basically 12 months of the year, we are going to iterate over those, and each time we're going to subtract and total out the monthly payment for each month, and then we are going to add the interest rate, the interest. In order to do that, this is how you do it. New balance times the annual rate plus 1. That is going to be divided by 12 to get your average there. Okay, now we're going to go into our if statement. If the absolute value of the new balance is less than or equal to 1 cent, then we're going to return the rounded to 2 decimal places payment. So that's going to mean that we found the lowest payment. If it's less than or equal to 0.01. New balance. Less than 0, then we are going to run the find payment function again, but instead this time we are going to replace the payment amount with something lower or something higher. No, it's something lower, I'm sorry. Yeah, so you're going to, if the new balance is, I forgot that, less than 0, then then our payment was too high. And then at that point, then we are going to replace that payment with something lower and run that iteration again. Now, finally, on the last part of this this statement, if it doesn't return a payment that is, or if it doesn't return a balance that's below 0, where the payment was too high, and it didn't automatically find the lowest payment from the first statement in this if statement list, then it's going to return and run the function again. And this time, I can get that right. This time, it is going to replace it's basically saying that the payment was too low. We didn't reach close enough to 0 or the 0.1. So we need to replace that payment with a higher number. So this is kind of how it's going to go through and look through each month and run these payments through each of the 12 months and see if this is going to give us the end balance that we want, which is essentially 0. So now that we've got all of our logic in there, now we can start plugging our variables. So you balance 5,000. Annual rate is 0.18. The low payment is going to be calculated like this, where it's just the balance divided by 12. So it's going to give you literally the lowest payment that you could have in 12 months to pay off the balance of $5,000 without interest. And then this is how you're going to calculate the highest. It's the balance is the balance times 1 plus the annual rate divided by 12. And then finally, payment is going to equal the find payment, the value that find payment function finds for it. It's going to go over the same arguments. And then at the end of this, we're going to print. And let's run it and see what we get. So you've got a syntax error. Alright, first thing. Forgot my colon. Okay. Let's try this again and see what happens. Let's see, recursion error. Okay, so there's a problem with these two. Okay, I see what I did. Needed to do it like this, so you're only accounting for part of that yearly interest. Let's try this one more time. Okay, 451.63 is what we came out with. I think this is correct. It does look a little bit different than this one is by about 5 cents. But essentially they're very, very close. So this seems to be a really good way to calculate it, and also a good way to just plug this into other places and to be able to use this in other ways. So yeah,